Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here unit number 2, Embedded Engineering User Interface. So in that content we are going to discuss here additive manufacturing. So first of all we'll look at the introduction about additive manufacturing. So it is a process of creating a 3D object by adding one layer of material over the another layer until a full object is created. So it is also called as 3D printing, and this is a technology where a three-dimensional object is created by laying down successive layers of material. The 3D printing is achieved using an adhesive process where the successive layers are laid down in different shapes. So this is the two methodology for forming a additive product. So it is differ from substitutive manufacturing because in a substitutive manufacturing we have to remove the material, but in case of additive manufacturing we can add the material and the finalize the product. So this is the best scenario regarding the additive manufacturing. Now we discuss regarding the what is 3D printing. So 3D printing is nothing but additive manufacturing. So where 3D is nothing but three-dimensional plus printing, that is 3D printing. So three-dimensional printing is there. So this technology used for printing physical 3D object from digital out is called as 3D printing. So for that purpose, a person can create a 3D image of atom using a CAD software, and after that it can slicing with the help of different softwares like Cura, and then if you create this G code, and then we have to finalize this component and we have to fade into the 3D printer with a machine setting, and then this starts to depositing a material in a layer by layer manufacturing. So this creates a platform on this bed, and after that we have to finalize this component. So this is the 3D printing, and this technology is uh, added for layer by layer technology, you can say uh, that manufacturing technology, and it can diverse effects of visualization of tool in design. It can means that uh, create a highly customized product for consumer and professionals. It also used to need the industrial tooling. Also, it is used to produce a small lot of production parts. So this is regarding the 3D printing. Also, it is useful for launching a new product. For that purpose, we have to create an object, and after that, we have to that testing will occur. And after finalization of this product, we can go for mass production. So this is the main benefit of this 3D printing. So nowadays the more multinational companies uses a 3D printer, and we are to forming a new component. So this is regarding the 3D printing. Now we'll discuss regarding the types of 3D printing. So first is stereolithography, that is called as SLA. Second is the selective laser sintering, that is SLS. And then third 3D printing is the fused deposition model, or can say fused deposition modeling, that is nothing but FDM. So this is the machine called as a selective laser sintering, or can say SLS. This machine is called as FDM, that is fused deposition modeling. And the last one that is called as stereolithography, or can say SLA. So this is the machine. Now we'll discuss first the stereolithography, that is SLA. So this is the SLA was the first type of 3D printing which is created, and this type of 3D printing consisting of vertically movable vat and a horizontal movable UV light. Instead of link, the vat is filled with this container and with a type of resin. So type of resin is nothing but photopolymer, so that become exposed due to this UV light, and because of this photopolymers or that UV light, the resins are solidified and forms a single layer of desired 3D object. So this process is repeated for each layer and finalize this object. So this 3D object is completed, then this machine will stop. So this is called as stereolithography. So again I repeat here. So this is the container which is placed a vat, and this light source, or can say laser source, will be comes from the top of the surface. So after this adjusting this the platform, and after that UV light it falls on this resin. So this resin, or can say photopolymer, so that can solidifies by one single layer. So according to our object, so it can finalize, or can say this repeating the process for each layer, and this object is produced. So this is nothing but a stereolithography. So main advantages is its speed. Also the functional parts can be manufacturing within a day, and the disadvantages, it is a costlier. So this is called as the stereolithography. Now we move for the next method, that is selective laser sintering, that is called as SLS. So here the powder bed SLS, a layer of powder material is carefully laid down by leveler or ruler on the build tray. So here the material will can fit through this roller, and then this fill to the second cylinder, and after the laser will be striking on this object, so therefore that finalize the shape. After that uh, this cylinder moves down. So after completing this first layer, this cylinder moves down, and here this cylinder moves up because newly insert the material. So that is why it can be controlled through this roller, and this roller will control, so it follows the that selective laser sintering. So here we can forming a shape by single layer. So this is called as selective laser sintering. So in that case laser is important, and this resin also important. So that's why we have to use this different materials like ceramic, glass powders, then the plastics, metals. So this is suitable for this SLS. This SLA is the polymers cost is about 80 to $100, so or more per liter. So SLS powders cost between $300 and $600 per kilogram, and can be difficult to even purchase. So this is called as SLS. Now we move for the next method, that is fuse deposition modeling. So this is another type of additive manufacturing. So it is a process that can continue a filament of thermoplastic material. So here we can let the wire, or can say this filament, into this nozzle. So A is called as extruder, or can say a nozzle which is attached to this B point. So here nozzle with a extruder. So when this filament goes downside into the extruder, so in that case this thermometer, we can measure the temperature, as well that here the heater is there. So according to the temperature it can hits, and then this liquid metal which goes down. So after that this movement of the nozzle, so nozzle is moving in a x-axis, and this table, so I can say this that portion will be move in a y-axis as well as in a z-axis. So z-axis means, so the tool, or can say sorry, this bed, so bed can be changed the directions, so you can say goes downwards. So if one layer is formed, then this bed will goes down. So this is the z-axis. So this is regarding the fuse deposition modeling. So here this string of plastic that comes in one end. So instead of this UV light, the extruder nozzle is used. So this is most safest method for 3D printing. So here we can see that after heating of this filament goes downwards from the roller, and then if it liquefy this that material goes down, and this thin plastic bits will forms which is on a bed. So according to the programming, so it can move in a x and y coordinate system and then form is a component. So this is the fused deposition modeling. Now we move for how to do with 3D print using FDM. So first of all, we make idea or you can say object, so that create into 3D software. So in the market, there are a number of that software is there like NX or you can say soft that SolidWorks, then Fusion 360, etc. After that, finalizing the product, the next process is for slicing software. So after using this slicing software to slice this design and generate to the G code. So after that, we have to feed into the machine, and then this machine is turned on the 3D printer and load the filament, and after that we can choose the material. According to that, the material will be melted into this nozzle or can say extruder, and then it can forms the new shape that is called as FDM technology, and can upload for the print, and after that it can remove the model from this print and then remove these supports and smoothen the paint the object. So this is the scenario for 3D printing by using FDM. So this is the FDM technology already we discussed. So here we can create a 3D model into the software. After that we can slicing with the help of Cura software. So this is the number of layers we have to form here. This is called as layer by layer manufacturing. After that, this slice software is converted into G code, and this G code we have to feed into the that machine that is called as FDM technology. So here we have to vary the material. So according to your material, we can vary this color. So this is the main advantage of FDM technology. Now we move for the CAD model to 3D object. So here it is clearly mentioned that the object or can say this extruder, we can move to and fro it up and down. So this is the scenario regarding the forming a 3D object. So first of all, we forming a 3D card model, and we have to convert into .stl file. Then using slicing software, we have to convert into the required format. After that, slicing and generating a toolpath, we have to feed into the 3D printer, and it forms a 3D object. So this is the completed prototype car. Now we move for this is the layer by layer manufacturing. So first layer will form, then this bed goes down, second layer is formed, then lays down, then third layer. So likewise it can forms and finalize the product for 3D object. Now we move for the applications related with this 3D printing. So first application is design prototype. So in that content, the applications related with medical, food, car, games and entertainment, product design, defense and space, fashion and retails. So first of all, look at the digital that can say design prototypes. So 3D printing concept model, functional prototypes and presentation models for evaluating the refining design and packaging. So in case of education sector, the engages students by bringing the digital concept into the real world and turning their ideas into real life. After that, we discuss regarding the healthcare. So rapidly produce a 3D model into the reduce the operation time, enhance the patients and improve the patient outcomes. The next point is architecture. So rapidly produce a 3D model, concept model, produces a smooth detailed architecture model is an any array of materials including the rigid photopolymers. So these are the applications in architecture. So here architect Michael Hesimus and BGM Delin printed these components. This is complex shapes we have to formalize into the 3D printer. Then architecture models we have to form, then benches, then sculpt ratios, then lamp for lighting. So this is a major advantage in architecture. The next applications it is in food preparation to apply atoms or liquid or paste. There's such a cheese or icing and chocolates. Now we move for the medical industry. The physician can use a 3D printing to make a hearing aids, artificial teeth, and bone grafts 3D printed job. So this is a major advantage or I can say major impact of the application point of view. So this is 3D printed cast to help repair the broken bones, maybe future of medical orthopedic or can say orthopedic cast. 3D printed cast also bring out the positive potential of this emerging technology. Now we move for the future and conclusion. So with the 3D printer, if you print anything you want to use with tomorrow, if you lose your remote, you will be able to print a new remote. So this is regarding the future. In case of conclusion, the 3D printing is expanding technology which may soon start a industry in everyone has possibility of being a manufacturer. The 3D printers are always greater, cheaper and better. The next conclusion is for 3D printing has a lot of possible benefits to the society, although the products created must be regulated. The next future thing is within a decade, the 3D printing or can say 3D printers will become a commonplace in houses. There is currently research is going to create a 3D printers that could be print out organs for people in a need of transplant. So this is regarding the scenario for future. In case of conclusion, the 3D printing has been used on small scale projects in the construction industry, and there are a lot of challenges that need to dealt with prior to considering adapting it one of the main construction technology. So this is the advantage or can say conclusion about this process. So this benefits of this such a technology is endless. Now we take a case study for the canal house Amsterdam. So Dutch architect is making a 3D printed 13 rooms canal house. It is made from separate but interlocking components. So the room will be structurally internalized on their own and will placed on top of each other to make a house. So here the canal house is printed with the Kermer marker that can print entire interiors and measures 2 by 2 into 3.5 centimeter. The primary material being used for the bioplastic, and the bioplastic is created from rapeseeds and can be ground down and reused as necessary. Then Vinson have built a 3D printed measuring villa in a 1100 square meter. So this is a great achievement in a 3D using 3D printer. This 3D printer can use for making a different complex shapes. Now we move for the usage of 3D printing in India. So in education sector only 3% is there, architecture is 5.20, then aerospace we have measured but it should be 10.80, then after industrial 13.80%, then medical it should be 15%, and last middle list that is automotive that is 21.2. So this is the use of 3D printing in India. Now these new companies are enrolled for 3D printer. So that is Antlam Technology, Imaginarium, then Brahmas 3, Think 3D, then J Group Robotics. So this is regarding the company related with the 3D printing. In the next lecture, we will discuss regarding the user interface. In the last lectures, we have discussed regarding the all the things which is helpful to the manufacturing technology. Thank you.